Okay, so we need to be able to rewrite some of these expressions to use our natural logarithm form. And don't forget, what we're looking for here is somewhere where we can use the form du divided by u as our integrand so that we can take it to be the natural logarithm of the absolute value of u plus c. So the question is, where does this exist in our expression? Now you can see the difficulty right away, because if we let u equal 2x plus 3 as we should, we've got a little bit of a problem here, and the problem is that du would equal 2 times dx, which is to say 1/2 of du is equal to dx. And that would be the replacement we'd want to make right here, only where is that du, right? We've got this 3x plus 1 floating around. Well, the answer, of course, is to rewrite our expression, and we're going to use a change of variable to do it. We start with the fact that u is equal to 2x minus 3, and if we solve for u in terms of x, we might note that x is equal to 1/2 of the quantity x u minus 3, pardon me, right? So solving for x gives us x equals 1/2 u minus 3, and so what we're going to do is we're going to rewrite our expression. We're going to rewrite 3x plus 1 using that. So instead of saying 3x plus 1, we could state, well, 3/2 times u minus 3 plus 1. And then making the appropriate replacements right here, we find that, our expression, 3x plus 1, could be replaced with 3/2 u minus 9/2 plus 1, that's minus 7/2. And again, if you need to pause the video in order to take a moment and check this out algebraically for yourself, please do. But what we're going to do then is we're going to rewrite our integral, right? We're going to rewrite our integral in terms of this new change of variable. So here's the way I'm looking at it. I've got my integral of replacing 3x plus 1. I've got 3/2 u minus 7/2. I've got 1/2 du instead of dx. I'm just gluing that to my numerator over here. And then, of course, my denominator has u. Well, doing a little bit of fancy rewriting right here, this is going to give us actually two different integrals that we can subtract. The first one is going to be 3/4. We take 3/2 times 1/2. The integral of u over, oh, I had to replace that one, don't I? Not dx right there, Professor. It is du. Thank you. So we've got 3/4 times u over u du from the first case minus 7/4 times the antiderivative of du over u. And there's that du over u bit that we were looking for. So now we actually have that. And so let's go ahead and rewrite our integral one more time over here just to make it a little bit easier to see. We're actually integrating now the expression 3/4 of du minus 7/4 of the antiderivative of du over u. And now making that replacement again, making that leap, we get 3/4 of u minus 7/4 the natural log of the absolute value of u plus our constant. And now, of course, we're going to go back, we'll replace u, and we'll get our final expression right here for our integrand, which is to say we've got 3/4 times the quantity 2x plus 3. We could rewrite that if we wish to, but I'll leave it in this form, minus 7/4 times the natural log of the absolute value of 2x plus 3 plus our constant of integration. And with that, we're done with this great example.